Hello, today we're going to be doing some derivatives of antiderivatives. Say you're trying to take dx to a function that has some other variable other than x, but you still have x in the quadrants for b and a using the interval. First it'd be looking kind of confusing, you don't know what to do. I'm going to kind of step you through the process, make it a little bit more simplified for you. Just follow along with me. If you haven't watched my other videos, explaining what is the antiderivative, what is the derivative, all that good stuff, you need to stop and just go ahead and watch those because you're not going to understand anything that I'm doing. So, say we have the function, or say we have the problem where we're trying to take dx of the antiderivative with a base b being x squared and base a being x plus 3 with the function t over 1 plus t squared dt. So this is going to be a little confusing at first. You're not going to know what to do, but here's what you do. You're going to take your original function, and you're going to take your b, and you're going to plug it in wherever you can. So for base b, you would have x squared divided by 1 plus x to the 4th power. But then you need to multiply it by the derivative of that base b. So that's where you have your x squared prime right here. So this whole thing is going to be known as antiderivative b. Okay, so then you're going to subtract it by your f of a, which your base a is x plus 3, so the exact same thing that you did with the base b, you're going to do with the base a. You plug it in, here you're going to FOIL later on, and you take the derivative of that base b, and you subtract these both. This is the answer once you do all your magic math here. You can simplify it more if you want to, but the majority of the time they're not actually going to ask you to simplify it more than what they already got. So for simplicity reasons, this is your answer. Because here, we took the derivative, and here we took the derivative. We still have the original function, and that problem is good. So I have one more problem to show you guys as one last example. Say I'm taking dx, another dt. I have a base b and a base a. My base b is x minus sine x. My base a is x plus sine x. So then I have the square root of t. So just like I showed you in the other problem, you're going to plug in your base b. So now you're going to have square root of x minus sine x, and then you're going to take the derivative of your base b, which is this right here. Okay. Then you're going to subtract it by your base b, plugged into the original equation. That's what you got right there. And then you're going to take the derivative of it, which is this right here. Okay. The problem does look a little messy because you're using trig functions. And a lot of time you're going to see problems like that where you're using trig functions with a dx to a different variable. You'll see that a lot actually. And when you do this, you can simplify it more, but when you take the derivative of this, negative sine x is cosine x. Or negative cosine x, I apologize, and the derivative of x is just 1, so then you're left with square root of x minus sine x times 1 minus cosine x. That's your base a. That's what you got right here. Okay, then you do the same thing with your base a, plug that in, take the derivative, you find your derivative here to be 1 plus cosine x. You can actually rewrite this whole thing with the square roots actually being this. You could write it as parentheses x minus sine x to the half power times 1 minus cosine x minus x minus sine x to the half power 1 plus cosine x. That half power is just showing the square root symbol. There's a bunch of different problems and different examples you can do. I'll probably do some more before the end of the semester. So I will be back with you later. Remember, taking dx of some other function other than a variable, first thing you want to do is plug in your base b into the equation, then take the derivative of base b, then subtract that whole thing by plugging your base A into the original equation and then taking the derivatives of that, and that is all there is to it.